Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's episode, a new way to track space junk, an energy cell that lets you store solar energy for later, and the first grid-connected wave energy device in the US. There is a lot of junk in space, like a lot of junk. We're talking about 20,000 particles of junk that are at least 4 inches in diameter. That might not seem like a big piece of junk, but when you consider it's moving at a speed of 15,000 miles per hour and running the risk of damaging some very fancy and expensive satellites, it's a problem. Plus, when you combine the 20,000 pieces of man-made orbital debris with natural particles from meteoroids, there are a whopping 500,000 pieces of debris to contend with. This junk has a history of colliding with important technology too. In 1996, debris from a French rocket that had exploded 10 years earlier damaged a previously functioning French satellite. And every time something collides, it launches more pieces into space. When a defunct Russian satellite collided with a functioning US commercial satellite, it added 2,000 pieces of debris. There are a few different ways that this debris is being tracked, but none of them are particularly accurate. Better accuracy would mean more advanced warning when a collision is about to occur. With that in mind, the German Aerospace Center has received 25 million euros from the government to create a better system of tracking with an improved radar system from the Fraunhofer Institute for High-Frequency Physics and Radar Techniques. The system in question, Tracking and Imaging Radar Systems, will be used as the base for the project, but the version of the system being used to track these softball-sized particles in space will be much more sophisticated. The new version is called the German Experimental Space Surveillance and Tracking Radar, or GESTRA. It uses an electronically controlled antenna, which allows for quick reorientation to collect high-definition images. The unique setup utilizes phase array antennas, which allows the system to track many things at the same time with a high level of accuracy. The system will be used to track debris and satellites between 186 and 1,800 miles from Earth, hopefully starting in 2018.
Researchers at the University of Texas Arlington have found a way to store the electricity generated by a photoelectrochemical cell, also known as PEC, for extended periods of time and allow electricity to be delivered around the clock. A PEC cell is a type of solar cell that gathers the sun's energy and transforms it into either electricity or chemical energy used to split water and produce hydrogen for use in fuel cells. The issue in the past, however, was that the electricity generated by a PEC cell could not be stored effectively, and the electrons would quickly disappear into a lower energy state. The cells were not a viable solution for the clean energy grid since the electricity had to be used pretty much immediately after being produced. The new PEC cell includes a specially designed hybrid tungsten trioxide titanium dioxide photoelectrode that, unlike previous designs, can store electrons effectively for long periods of time, making it a now feasible option for smart energy grid. The system also includes a VRB, an already established type of energy storage cell that is well suited for the needs of the electrical grid, as it can stay idle for very long times without losing charge. The VRB works well with the hybrid electrode, boosting the electric current and offering great reversibility, allowing for high-capacity energy storage. The team is now working on building a larger prototype with the hope that this technology could be used to better integrate PEC cells within the smart grid.
A prototype wave generator called Azura is supplying grid power to Hawaii, making it the first grid-connected wave energy device in the US. The project, which is co-sponsored by the US Navy, will take place at its wave energy test site at a depth of about 100 feet. The prototype consists of a 45-ton wave energy converter that can capture energy from both the up and down and front and back motions of waves. It has an onboard generator to convert kinetic motion to electricity, which is transferred to the grid via an undersea cable. Though it can only produce 20 kilowatts, the DOE says that similar devices could eventually provide large amounts of clean power to coastal cities. The DOE plans to use this current trial as a foundation to design a new generator that will operate in bigger waves at 100 to 150 foot depths and generate up to 1 megawatt, which is enough energy to produce several hundred homes. That system could come online as early as 2017, but meanwhile, researchers will continue testing Azura over the next year. The data will also be delivered to the Department of Energy and the Navy for their use in ongoing efforts to validate wave energy technology and advance the marine renewable energy industry.
That's all for this week's video. Be sure to check in on Facebook and Twitter and view past episodes at ecnmag.com. For the ECN channel, I'm Janine Mooney, and this has been your Engineering Update. I'm nauseous actually now, so.
Really?